Okay, this is like the third time I'm making this video because my stupid Screencastify app was like apparently not updated. So, don't record like a whole like 15-minute video without checking to see if it will even record a 1-second video. Okay, so today we're learning about series. I'm making this video because the juniors are taking the cast and I thought it would be nice to have a video to look at instead. All right, so sequences and series. An infinite sequence is a function whose domain is a set of positive integers. Oh shoot, I'm just like kind of trying to follow along with your worksheet, fill in the blanks, make sure you have the option obviously to pause at any time. And then if you feel like you're understanding some of the examples, then you should try them on your own and then press play and then watch me do them. So an infinite sequence is a function whose domain is a set of positive integers. The function values like a sub 1 all the way to a sub n are called the terms of the sequence. The sum of the first n terms of a sequence is called a finite series or an nth partial sum of the sequence. Basically, like a sequence is like a list of numbers and a series is the sum of that. So a finite series is if you have just a partial sum of the sequence. The sum of all the terms of an infinite sequence is called an infinite series. So sequence is a list, series is a sum of a list. So here's an example. So here's a sequence. It's a finite sequence because there are exactly 4 terms. So in this case, like a sub 1 is 1, a sub 2 is 2, a sub 3 is 3, a sub 4 is 4. And a sub 1 stands for like the first term is 1, second term is 2, third term is 3, fourth term is 4, for example. And then the series is the sum of that sequence. So like 1 plus 2 plus 3 plus 4, which is 21. Okay. Okay. So then, so here's my next sequence. So in this case, a sub 1 is 3, a sub 2 is 6, a sub 3 is 9, and a sub 4 is 12. And this one's an infinite series because you can see of that 3 dots means it goes on forever. So series is the sum of that list. So I don't know why I wrote one. It's 3 plus 6 plus 9 plus 12 and so on. And the numbers get bigger and bigger, and so it actually like goes to infinity. You'll study more series in BC calculus and like why they go to certain things, but for now just hope you understand. A sequence is a list of numbers or a function with a domain of integers, and then a series is a sum of that list. So here's one more example. Here in this case, this is also an infinite sequence. In this case, a sub 1 is 1/2, a sub 2 is 1/4, a sub 3 is 1/8, a sub 4 is 1/16. In this case, the numbers are getting smaller. Okay, so when a series goes to infinity, you'll learn eventually that means it diverges. And then when a series goes to a number, it converges. And this one actually does go to a number. You can kind of figure out what it is just like, without knowing like the rules, right? Like 1/2, like here's like a circle, right? 1/2 is like there, right? And a fourth, if you add a fourth, right, then that much of the circle will be covered. If you add an eighth, then that much of the circle will be covered. If you add another 16th, right, and then you can see this circle slowly gets closed. That's because this infinite series does go converge to the number 1. So you add infinitely 1 over, powers of 2, you do get 1. Okay, so sigma notation. So the nth partial sum, or as some n, is denoted by this, where I is the index of summation. So like this letter I is the index. The ith term is ai right here. The upper and lower bounds are 1 and n. And the summation notation is called sigma notation because it uses the uppercase Greek letter sigma. So like this here is a sigma. Okay, so it's just a notation. Let's practice going from sigma to series. So this is a notation for a series. Again, this this index, right, is your variable. This is like your formula. This is your start, and this is your end. So then your formula is just I. So when I is 1, it's 1. And then you go up to 6. So when I is 2, you have 2. And then 3, and then 4, and then 5, and then 6. And then you should get 21. Oh, I think I said the other one was 21. The other one's 10 from before. 1 plus 2 plus. Did I say that was? I don't know. I'm like losing my head. This is the third time I'm doing it. I'm furious. Mostly with myself. I'm smarter than this. Okay. So, all right. Okay, so now pause and try another one on your own, and then when you're ready, you can watch me do it. Okay, so this next one, you can see your variable is k, you start at 3, and then you go to 5, and then you plug in 3, then that's 3 minus 2, then plug in 4, 4 minus 2, then plug in 5, 5 minus 2, right? So this is your formula, and then you plug in the numbers 3 through 5. So you plug in 3 first into this, then 4, then 5, because this is your start and this is your end. And then you get 3 times 1 plus 4 times 2 plus 5 times 3, which is 3 plus 8 plus 15, which is 26. Okay, so now let's go the other direction. So you're going to go from series to sigma notation. So here's like a series. What's important really is just to look at like what's changing. So for example, like, or really what's not changing at first. So like these 3's are not changing. So you can say like, it's like the sigma, and then it's like 3 like over something. And then you can see like these numbers are like 10 to 1, 10 squared, 10 cubed. So they're all 10 a power of 10. So 10 is not changing. So what is changing is like this exponent here. So it goes 1, 2, 3. So then if that's what's changing, like that's our variable, our exponent is our variable. So K, I'll just call it K. And then you just kind of want to look at like what is your start and end of what's changing. So it starts at 1 and it ends at 3. And there you have your sigma notation for that series. Okay, so try the next one on your own, and then when you're ready, press play. Okay, so the next one, you can again look for what's changing, what's not changing. So you can see like these 1s are not changing, these 4s are not changing, these squareds are not changing. So you can put those all in your sigma. So you have like, oops. Dang. Didn't mean to do that. Whatever. I don't care anymore. Okay, so like there's your 1s. Here's your 4. And then there's your 2. So what is changing, right, is like the numerator of this fraction, right? You can see like here it's 1, here it's 2, here it's 5. So that's what's changing. So you want to put a K there, and then that will be your variable. And then you look at like where it starts and where it ends. So it starts at 1, ends at 5. Okay. So there's some properties and rules. So this first one saying if you multiply by like a coefficient, you can like pull it out. So if you have like the sigma like 4x, you can pull out the 4 in front. This one kind of like implicitly says that if this were C, then this is the formula. So like, for instance, if you had like some constant, let's say like 5, if it's constant, it's 5 every time. So really you're like adding 5 to itself like 6 times, right? Because the first term would be 5, the second term would be 5, all the way up to the 6. They would always be 5 because that's the formula. It's always 5. So then really instead of doing that, you can just do 6 times 5. So you can like multiply these. And then these are just saying you can like split up your sums over addition and subtraction, just like we can do with derivatives and antiderivatives. Okay, and then these are some formulas for specific, or rules for specific formulas. So if you have the formula, sorry, if you have the formula K, you have that rule, K squared, that rule, K cubed, that rule. You'll see when you do these examples. Okay, so it says rewrite the following without summation, then evaluate. I'm just gonna evaluate on my calculator. This is like the third time that I'm doing it, so let's just save some time. Save you some time as well. So, this here, the index, right, like refers to like what your variable is. So I know I have like multiple letters in here, but this is my variable. So anything that isn't that, you can bring that out. Like basically this like over n squared, you can pull out. So it's 1 over n squared.